Yeah. Good. I was starting to freak out.
Really not being sick anymore, so let me diagnose
Well, I'm going to go ahead and start the lecture. Yes, I am having a bad hair day today, but, it's okay. It's out of my way. It doesn't bother me at all. Okay, so what we'll do today is we'll continue our discussion of passing by reference. I changed the program. Remember last time, on last Thursday, I changed the program from passing by value to passing by reference. But all I did was to change the syntax of the program. So what we'll do today is to find out exactly the mechanism of passing by reference and how it is going to help us solve the problem. So let me first, repeat the program first. I'm going to retype the whole program, which won't take too much time. If you have already copied, the program from last time into your notes, you don't have to do this again. Or you can just wait until, we have the recording, online. Then you can, do it, at that point also. I'm gonna do not do any recovery and start a new spreadsheet. Okay. So let's go ahead and retype. Let me just kind of retype the whole program. It may not be identical to the one before, but it will be close enough. Okay, so we have a subroutine called swap. What it needs to do is to exchange the values of two variables. But I want those two variables to be something that does not belong to this particular subroutine. Because if the two variables are either local variables belonging to swap or they are by value parameters, by the end of the execution of the subroutine, it is as if nothing happened, right? Because both local variables and also by value parameters are allocated on a per invocation basis, and at the end of the invocation, they all get deallocated, okay, as if nothing happened. So instead of using those constructs, I'm using a passing by reference mechanism to deal with x and y. I still have a local variable t because it is just only needed within the subroutine. It is not needed from outside of the subroutine. And then the code is identical to what we had on last Thursday. I use t to store the old value of x before x is changed. X will then get the value of y. Y is then going to get the value of t, which was the old value of x. So therefore, we should have exchanged the values between x and y. Okay, so the code here is almost identical to the one that we used last Thursday, except the parameters x and y are now passed by reference instead of passed by value. So the focus today is basically, or at least at the beginning, our focus is what do we mean by passing by reference and how is it different from passing by value? And when we trace the algorithm, it will be very clear. At this point, we are also going to change our standard to be more conforming to the C standard, which means we use a main subroutine to start execution, whereas before we have global variables and we put code outside of the definition of a subroutine. So in this case, we have local variable I, local variable j. I gets a particular value. This may not be the same value as last time, but it's okay. It doesn't really matter. And then we invoke the swap subroutine. Now here we have another syntactical change. Is when in this class in pseudocode, when we pass parameters by reference, instead of using a single-sided arrow, we use a double-sided arrow for a specific reason. So instead of just saying, I is used to specify parameter x, I'm going to use a double-sided arrow. Can anyone just kind of, give it a guess why we are using a double-sided arrow instead of a right arrow?
Because it passes it from the subroutine back to the
to variable I.
Yeah, to variable I in line 12 of the program.
Right. Whatever we do to parameter x actually happens to local variable I, and that's why it's a double-sided arrow because it goes both ways. Okay. The value of I is accessible to parameter x, but whatever we do to parameter x is also going to be happening to variable I in this case. So that's why it's a double-sided arrow. In other classes, in the actual C programming language, there are no such thing as arrows. You don't even name the parameters. You just do it by position. In other words, in this case, parameter X is the first one, parameter Y is the second one. In C, C++, and most other programming languages, you just say I, comma, J. In other words, it is implied that I would go to the first parameter, which is X, and J would go to the second parameter, which is Y. But in this class, I make it very explicit which one is going where, just so that we are aware of how the argument, which is I and J in this case, are linked to the parameters which are X and Y. Okay? So I just want to make sure that we understand, this is not a standard syntax in a regular programming language, but in this class, I choose this representation because I think it is important to, make that clear. All right, so now we have the entire program basically retyped, and we want to trace it. So we go ahead and trace this with a new window. We'll probably stop a few times, during the trace because we have some kind of new concept that I have to explain. I'm hoping that most of you have read the text, the notes from my website over the weekend, over the past 5 days or so, because it is a kind of more difficult concept to understand compared to local variables and by value parameters. This one is a little bit strange, a little bit different from the other two. Okay, but yet, at the same time, it is, very much related to those concepts that we have already talked about. Okay, so we have line number. We don't have any comments because there are no conditions to evaluate in this case. The precondition has got nothing to say. Yep.
Sorry, I know I should know this by now, but what does by reference mean again?
By reference, well, it's not a. It's a new concept that I'm explaining today, so we have not encountered that concept before.
Okay.
So that's what I'm going to explain today. But I was hoping that most of you would have read the notes ahead of time, so we have get a rough idea of what it is, or at least what it's trying to accomplish before today's lecture. Okay, so we have precondition. I have nothing to say about the precondition, because if you look at all the names, they are either parameters or they are local variables. So we'll start with T here. T is a local variable. X is a by reference parameter. Y is a by reference parameter. So all the names referred to by subroutine swap are now accounted for. None of them can be a global variable. Same thing applies in main. I is a local variable. J is a local variable. And those are the names that we refer to in subroutine main, so it doesn't have any global variable reference. We don't have any global variables at all in this program. So the precondition has got nothing to say. Now we start execution on line 16, and it invokes main. We have a return line number, which is post, because that's the line 16 is the last line of the entire program. But we also have to allocate for the local variables I and J. So this is nothing new. We talked about local variables last week already. So this part is just something that we already know what to do. And the allocation of all of these columns, columns B, C, and D, are from the leftmost available columns. Okay, so that part is really important because we don't want to just randomly start to allocate some columns. It has to be from the left side of the spreadsheet, and it has to be the leftmost available column in this order. Now that we have all the columns allocated, we continue execution on line 12. That's pretty easy. I mean, we have local variable I getting a value of 3, and then on line 13 we have local variable J getting a value of 7. No big deal. We know how to deal with all of this already. And now we're on line 14, which is going to start with something that we are learning today. That's new, for this class. We're invoking swap. Okay. The first part we know. Okay, we need a return line number so that when swap is done, we know where to go to continue execution. That part is nothing new, and we know that the line is going to be line 15 because line 15 is n defined sub. We actually have something to do at that point, so that part is okay. We also know that T is a local variable, and all local variables start with some unknown value. So we put a question mark on column H, and that part we know as well. X and Y are parameters, and as parameters, they are always allocated on the fly, just like all the other parameters and also local variables. So we are allocating column F and column G for parameters X and Y. The question is, what do we put in those columns? That really is the big question. Before, when we passed by value, all I'm doing is to evaluate the expression I and say, well, that becomes the value of X, which means, it is 3 here, and Y gets the value of J, which is 7. That's what we did before with passing by value. But now that we are passing by reference, this is not what we're going to do anymore. Instead, parameter X becomes an alias of the column that also has a name of I. Okay, so the way I represent here is just using the alias alias terminology. So X is also known as column. In this case, the column that contains variable I is column C, and then the column that contains local variable J is column D. Now, it is very important that X is not an alias of I. X is an alias of column C.
Why?
That part is kind of important. Yep.
Why?
Because if you refer to I, there may be multiple local variables I's to the left of column F and column G. Okay, but if you refer to column C, there's only one column C. It cannot be ambiguous. So that's why we refer to a column. But that's only one reason. The second reason is inside the computer, when your computer processor is executing your program, it only refers to columns. It doesn't refer to the name of the columns. In other words, column C at this point has 2 names. One name is I, but that name is only known by the main subroutine. The second name is X, but that name is only known inside subroutine swap. And that's why X is known as an alias, because it is the same name for a column that is somewhere else. But the alias itself is taking up a column in this case. Is that okay so far? Okay, I'll give you an analogy later on. In fact, I'll give you 2 analogies. One for people who like sci-fis, and the second one for people who do not watch sci-fis. Okay, people who don't watch sci-fi do not necessarily do not like sci-fi. Maybe they just don't have the exposure of watching sci-fi. Maybe the entire family don't like sci-fi, and therefore, as soon as they switch the channel, it's like, okay, we need to switch back to something else. Okay, but I'll use 2 analogies, and hopefully one of those will work for everybody in the class. Okay, so this is how we set up the columns. Now we go to line 5 to continue execution. Continuing execution on line 5 is not that challenging because the right-hand side of the assignment statement is just saying X, okay? And you look up all the columns, which one has a label X? Oh, column F has a label X, which is known to the subroutine swap. You look up what X is, oh, you know what? It's an alias of another column. So you have to track down the column and find out what is the value in the column that X is referring to, and hence the name reference. Okay, so X is also known as column C. Column C has a value of 3 at this point, so that's why the entire right-hand side of line 5 just gives you a single value of 3. Okay, and that's what we're going to store in T. So we'll put it here. Excuse me, no soft drink during the class. Sorry. All right. So now. That's done, okay? That's not the most difficult part. The most difficult part is what do we do on line 6 and also line 7? Because now we are storing something on the left-hand side which is referring to a pass by reference parameter. Let's look at line 6. Line 6 is once again an assignment statement. The right-hand side is just Y. Y is an alias of column D. Column D currently has a value of 7. So the right-hand side of the assignment statement is just saying 7, okay, the value 7. No big deal, we know how to deal with that. The question is, what do we do with the left-hand side? In other words, we're supposed to store 7 to X. So the question now is, are we going to store that in column F? or are we going to store it in the column that it refers to, which in this case is column C? In other words, should I update this cell, or should I update this cell here?
C.
Column C, yep. So we are going to update this column, so now it has a value of 7. Okay, so now is a good time for analogies, okay? For those of you who watch, sci-fi and, especially Stargate, yeah, parameter X is a Stargate. That's all it is, okay? So it's a miniature Stargate, okay? And you just dial it to column C. So during the execution of swap, that particular invocation, you have a miniature Stargate here. Where whenever you're supposed to get something, with X, you reach into the Stargate and grab whatever the Stargate is connected to. In this case, that Stargate is connected to column C. Yep.
So we're never actually storing anything in the by references?
The column itself never get changed.
Because
In other words, you're not
refers
changing
to
the
C.
Stargate itself, you're using the Stargate to go to the container that it is connected to.
Okay, that makes sense.
Yeah. Yeah. So the column is actually, AKA column C in Stargate terminology is the address of the destination.
So when you're on line 6, when you're saying X gets Y, are you basically reaching in through G, pulling out the value?
Yep, you're using
and
two
putting it
Stargates.
into X?
Yep. You're using one Stargate that is labeled Y. Okay, to you it's just Stargate Y, right? But it is already dialed to column D. So you reach into that Stargate, grab something, and say, I'm going to make a copy of this and put it into the other side.
I like that.
Okay? Okay, if you do not watch Stargate, then you might have a question of what exactly is a Stargate? That's okay. We'll use a low-tech example in this case. The low-tech example is to use books versus books in the library. Okay, that's the example that I'm going to use. When you pass by value, which is the only way we knew how to pass something as a parameter before this class, is a by value parameter is like an inbox. Okay, but it's not exactly like an inbox. It's like an inbox, but it's a copier. Okay, so if I want to pass something, okay, so let's say I want to pass this piece of paper into the inbox of an office, I put this paper onto the quote-unquote inbox. But the person who's inside the office, in order to start working, that person is going to push the copier button and make a copy of this piece of paper, and then only work on the copy itself. So the person who's putting this piece of paper on the copier, which is the caller or the code that is invoking the subroutine, I'm safe. Nothing is going to happen to this piece of paper because whoever is in the office is only going to work with a copy of this piece of paper. Are we doing okay so far with that analogy? Okay. Passing by reference is, okay, I'll use another example in this case. Passing by reference is required if you want the original copy to be changed. Okay. In other words, let me pretend to be, a subroutine that will do proofreading. Okay, I'm a proofreading subroutine. So in order to do my proofreading, somebody has to give me a book to proofread. Is that making any sense? My job is to go through the entire book, spot all the spelling mistakes, grammar mistakes, and whatever can be wrong with the book, mark it up, and then give it back to the person who gave me the book to begin with. That's my job. If the book is passed by value, it means somebody is making a photocopy of the entire book, and I'm working with the copy inside the office. So I'll mark it up, start to scribble all over the place. At the end of the entire operation, what am I going to do with that book as a subroutine? Well, not exactly nothing. I'll throw it back into the recycle bin.
We'll hand it to the author and be like, here's the copy, It's not,
Because it's just a copy, right? And the copy is only accessible from within the office. Whoever gave me, quote unquote, gave me the book, left the book on the copier. Nothing happened to the original book. Am I doing okay so far with that analogy? passing by reference works this way, okay, and it's completely concrete in this case, no Stargate, involved, okay. So passing by reference means whoever is asking me to proofread a book is not giving me a book. That person, which is the code that is doing the invoking, is giving me a little slip of paper called a call number. Does everybody know what is a call number in the case, in the context of libraries and checking on books? Okay, so that's a call number. And that person will put the call number on the copier, the in tray, and I will push the copier button and make a copy of the reference number. Go ahead.
Is that why we know to put the alias with X and Y instead of I and J? Because that's why I was confused. You say invoke swap and you have I and X and you have J and Y on line 14.
Okay.
And then how do you know to put the alias with X and Y and not I and J?
How do I know to put the alias of?
Well, either one. Couldn't you have put under I, you could have put AKA column F. Would that be the same thing?
No, because I is a local variable. So to the local variable, that column is labeled I, and also the next column is labeled J. In other words, from the subroutine main's perspective, column C has a name of I, and column D has a name of J. So within that subroutine, I can refer to those columns as I and J. But those names are only known to main. They are not known to swap. In order for swap to access those two columns, I need this mechanism of passing by reference.
Okay.
Okay. Now back to the analogy of the book. Okay. So in this case, passing by reference means somebody is giving me the call number of a book instead of a book on the copier. So I'm still doing the same thing. I'm still pushing that button on the copier and making a copy of whatever is on the copier. But remind me again what is on the copier. A reference number, a call number, right? So now I have a copy of the call number. What do I do with the call number or reference number?
The library.
So I know where to find the book in the library, okay? So this way I can go find the original book myself, and as I do my proofreading, I'm actually doing it to the actual book. At the end of the entire operation, I have to toss away everything that I made a copy of. The copy, I have to toss it away. What am I tossing away this time? The book or a little slip of paper with the call number, right? Is it okay for me to trash and shred that little piece of paper with the reference number? Would anything happen to the book that I just marked out? No. Absolutely not. So that's what passing by reference is you are telling the subroutine where to find the original item. Okay? Are we doing okay so far with that concept? Is at least one of the analogies working with you? Okay.
But can you undo it?
Hmm?
Can you undo it?
Can I undo what?
Well, that alias.
No.
No?
No, because X is basically an alias of column C. Whatever you do to X, you are doing it to column C. So it's not undoable, because you are changing column C right now. I am marking up the book that I checked out from the library. Okay. All right. On line 7, once I can explain line 6, line 7 is pretty easy. Go ahead.
I was just curious if you could assign multiple, for in the first subroutine, could you have multiple by references, I guess, or one
to the same thing,
multiple local variables?
Yes. Yep, you can. Yep.
How would you change the alias of column F or G, like for X and Y? Like how would you say?
Once you, only the invoke statement, which is on line 14 in this case, only that statement has any control over, what column F is an alias of.
So if you were to finish with define subswap, and after, in between lines 8 and 9, you added something else that said I gets Y and J gets X, then they would switch.
No, because between line 8 and 9, that code has no access to local variables nor parameters.
But if, okay, so bad spot for that, but if you did add that in so that it would go to another swap.
You can invoke another swap game.
You mean between these two lines, if I add...
Well, not necessarily between those because you couldn't access those, but
Right.
if instead of going to post or something like that, you went to another swap and repeated, could you have the two aliases switch somehow or get different aliases?
They can potentially get different aliases. The aliases are controlled by the invoke statement. In other words, the invoke statement is what determines what X is an alias of and what Y is an alias of.
But it's not fixed.
It is fixed as far as an invocation is concerned. It is not fixed as far as the subroutine is concerned. So it depends on the invocation, depends on the invoke statement to determine basically how you set up the aliases. Okay? All right. So I can give you another example just by exchanging these two parameters after line 14. Okay, on line 7 it's simpler because on line 7 the right hand side is t. T is my local variable which has a value of 3. The left hand side is y. Y is an alias of column D, so column D is the one that will get updated to a value of 3. And now we move on to line 8. Line 8 is still doing pretty much the same thing as always. The first thing it needs to do is to look up the rightmost active return line number, which is column E. Column E tells me that I should continue execution on line 15, so I make a note of that. And then I can remove or deallocate these 4 columns. So all 4 columns are deallocated at this point when I return from the subroutine. But that's okay, because what I'm destroying is not the content of column C or column D. All that I'm destroying are the aliases of column C and column D. Basically a little slip of paper with a call number to a book. I'm not doing anything to the book itself. I'm just destroying the little slip of paper that has a call number on it. Are we doing okay so far with this example? Okay. So now back on line 15, things are just pretty easy at this point. Line 15 is also the end of a subroutine. We look at the rightmost active return line number. It tells me to continue execution at post. Make a note of that, and then we deallocate those 3 columns that belong to this invocation. And we're done with this particular trace, because now we are executing a post, which means we're at the finish line. Any questions about this particular example? Yep.
If you continued in the swap subroutine and you continued to reference after you made the swap,
Okay.
would X refer to 7
Yes.
now?
Yes.
Yeah? Okay.
It is always referring to the most up-to-date value of that column.
Okay.
Yep. All right. So if there are no questions about this, I can give you another example. Okay, so let's go ahead and do with another example here. Okay, in the next example, I'm going to say define sub transfer. Okay, and I'll make this one a little bit tricky. Okay, so we'll say by reference origin. Okay, where the money is coming from. By reference destination, where the money is going to. By value, how much? Okay, so this is just the amount of money, and the code is fairly easy. I'm going to decrease this much from the origin, the account that I'm transferring from, and then I'll go increase by this amount at the destination. Okay, so it's kind of like transferring money from one account to another account. And define sub. That. And in my main subroutine, this is where the tricky part comes from. I have a single local variable that I'll just call, let's just call it X here. X has to start with a particular value, so I'll just say that there are $200 in the account. What I'm going to do next is going to be something kind of funny, because I'm going to invoke transfer, but I will use X to specify both parameter origin and destination. So I'm going to use X to specify origin, use X to specify destination, and I'm going to transfer $20. Okay, $20 is going to specify amount, and define sub, invoke main. That's my sample program. Let me fix the indentation first. So the question is that really going to be okay? In other words, is it going to do quote unquote the right thing in this case? I'm going to change this a little bit, just so that I would use source and destination instead. It just makes it a little bit easier. It doesn't take up as wide of columns. So I'm gonna, oops, AMT. I'm just gonna change it so that it doesn't take up as wide of a column.
So you change X to B for balance.
Hmm?
You change X to B for balance.
Oh. Well, that's the amount. Yeah, I suppose.
Yeah, whatever.
Okay, so this way I can just save a little bit of space. Window, use a new sheet to trace it. Okay, so once again, the precondition has nothing to say because I do not have any global variables. On line 13, we invoke the main subroutine, set up the return line number to be post. We have one single local variable X, which is occupying column C. At this point, it has an unknown value. Every local variable starts with an unknown value until it is initialized. On line 10, that's what we're going to do here is to initialize local variable X, so it becomes 200. And now on line 11, we are invoking transfer. First thing is to set up the return line number to be line 12. That's the easy part. Now we have to think about what to do with the source, the destination, and the amount. The amount is the easy one, because when you look at the original code, the amount is specified by a particular constant, 20. Okay, 20 is easy. What do we do with source and destination in this case? Okay, so let's see how we specify the source. We are using local variable X of main to specify the source. Variable X of main is occupying column C at this point, so the source is really an alias of column C. Oops, AKA column C. There you go. What about what about D? What did I use to specify D? The same thing. Okay, so that means D is also known as column C. So now column C has quite a few names. Okay, let me just go ahead and try to show the entire thing.
Well, it doesn't have quite a few names. It has quite a few
References.
references.
Yep.
Yeah.
Well, it has a name. It's known as X inside the main itself as a local variable.
Right.
But inside transfer, it is known as parameter S as well as parameter D. Okay, both source and destination are now referring to the same column, and there's nothing wrong with it. Okay, it's perfectly okay to have multiple pass by reference parameters referring to the same thing. Okay, there's nothing wrong. So we'll go ahead and see what happens when we execute the code inside the subroutine transfer. So we continue execution on line 5. Line 5 is going to calculate origin, or I have to change all of these too. And change this one. There we go. All right. So on line 5, we are going to perform the subtraction. Parameter S is passed by reference. It's referring to column C. Yep. All right. Row sheet is right here. Oh, I think I got the wrong one. I keep forgetting to make a new row sheet for this class. I have a new one for the other class, but I keep forgetting to make one for this class. on line 5, the right-hand side of the assignment statement is trying to compute the difference between source and amount. Okay, the source is column E. It's an alias of column C. Column C currently has a value of 200. So we are subtracting 20 from 200, which is 180. Where are we going to store that result? We're storing the result back into source, which is an alias of column C. So column C is the one that is now updated to a value of 180. Are there any questions about this step? Why column C, which normally would not be accessible from transfer, is now getting changed? It's because we are passing by reference. The parameter is passed by reference. It is telling transfer which column it is actually referring to. Are we doing okay so far? Okay. The next line, you can probably guess what it's going to do, is just to undo what the first line did. Because on line 6, we are now trying to add 20 to whatever D is referring to. D is a reference to column C. Column C at this point now has a value of 180. So I'm adding 20 to 180, which is 200. Where am I going to store the 200? Well, the left-hand side is parameter D. Parameter D is an alias of column C, so the 200 is now stored back into the same column, which is column C. Are we doing okay so far with lines 5 and 6? There's no problem. Okay, you can definitely have multiple pass by reference parameters referring to the same column. Now we continue execution on line 7. You probably know what's going to happen here. We refer to the rightmost active return line number, which is here. Make a note that we have to continue execution on line 12. Indicate these 4 columns are now deallocated. And then continue execution on line 12. Line 12 is the end of the main subroutine. We'll do pretty much the same thing. Refer to the rightmost active return line number. It tells us to continue execution at post. Then we will deallocate those 2 columns. And that ends the entire trace.
What was the point of that? That seems stupid. It doesn't look like it would work for anything. The way you put 2 of them under X or column C.
But this is just to illustrate you can have multiple pass by reference parameters referring to exactly the same column. It doesn't cause any problem by itself.
If there was like a conditional there too, like around 5 or 6, it could be more useful, like in a bank program or something. But yeah, this looks like it was just for demonstration.
It's really just to illustrate the concept that you can have 2 parameters passed by reference, but they are referring to the same column. It's just to illustrate. There's no problem with that approach. So now would be a good time to rewrite our factorial program again to make use of pass by reference. All right, so I'm going to use this one to rewrite the factorial subroutine. So rewrite factorial. Okay, this time factorial will use by value to pass n. N is the number of which the factorial I want to compute. In other words, I'm trying to compute n factorial. So this is definitely coming in only. The result, I want to pass it back by parameter r. Okay, and it's passed by reference because I need to change the value of somebody else's column that is not directly accessible to me otherwise. Okay, the code is pretty much the same. If n equals to 0, then I know the result is supposed to be 1 because 0 factorial is 1. Otherwise, I'm going to do the following: invoke factorial, but the new n is going to be 1 less than the n that I got. But I want that result to be stored at the same place where I'm supposed to store my result. So after the invocation of factorial, I know one thing for sure. R, parameter r, is now going to refer to the result of n minus 1 factorial. So if I know n minus 1 factorial is stored at whatever r is referring to, hey, I can do n factorial pretty easily, right? Because n factorial is n minus 1 factorial times n. And that's my job, is to finish up this operation. And that's the entire subroutine factorial. I'll define a subroutine main, just so that we're SUB. There we go. Local variable R to store the, well, let's call it X. And then we'll say invoke factorial. And let's use 3 this time to specify n. And then we'll use local variable X to specify parameter R. And define sub, invoke main, and that's my entire program. Fix the indentation first. Using a spreadsheet actually makes indentation a lot easier compared to using just a regular text editor. All right. Are there any questions about the code as it is right now before we start tracing it? Yep, go ahead.
The R gets the alias of R. That's a little confusing.
Well, I'll explain that. It's basically, okay, using the analogy of the library analogy, okay? So remember, I'm the proofreader, but let's say, I'm a lazy proofreader and I want to subcontract the spell check to somebody else, okay? Remember, what do I have? What do I have? On my hand. What is passed to me? The book or the call number? The call number. Okay. So now the question is, if I want to subcontract spell checking to somebody else, what am I going to give to the subcontractor? The call number, right? Or should I give the subcontractor a call number of my call number? Just the call number is fine, right? Because all I want the subcontractor, the spell checker, to be able to do is to find the book, not the little piece of paper that has my call number. So I just want to say, okay, spell checker, I want you to spell check this book and mark it up for me. So what I'm going to do is I'm going to take the call number that I have in my hands and just say, okay, here, take it in your inbox. So R goes to R on line 7 is only going to make a copy of the alias itself. It's not going to create an alias of an alias. Okay, so remember, in this class, we do not have an alias of an alias. Passing by reference cannot generate that kind of situation. In C, you can because you have pointers, but we're not going to talk about pointers in this class. All right, so that's the code. Let's go ahead and trace it. This time we do have conditions, so we have to have a comments column to keep track of the conditions. And the precondition has nothing to say because we do not have any global variables. On line 15, we invoke main. We remember the return line number to be post. We have a local variable x starting with an unknown value. Okay. Then we continue execution inside the main subroutine starting on line 13. And on line 13 is invoking the factorial subroutine, which has its own return line number. The return line number is going to be line 14 because the invoke statement is on line 13. It has 2 parameters. It has parameter n, which is passed by value. As it is passed by value, I just say, oh, okay, the value is supposed to be 3, so the by value parameter starts with a value of 3. No problem. Parameter r is passed by reference, which means I have to figure out where x lives. Okay, x is a label of a particular column, and that column turns out to be column D in this case. So that makes parameter r an alias of that same column. So we say it is also known as column D, and that's how we set up the 3 columns when we first invoke factorial. We get into factorial, starting on line 4. We evaluate the condition. N equals to 0 is false because n at this point has a value of 3. So we go into the else branch starting on line 7. Line 7 says I want to invoke factorial again. Okay? The fact that I'm invoking factorial from inside factorial is not even important. Okay? Because the mechanism of invoking a subroutine does not even matter where you are doing the invocation. So we're going to do exactly the same thing. We have to set up the 3 columns. The 3 columns that we are setting up are return line number. And in this case, because the invoke is on line 7, when it is done, we have to go to line 8 to continue execution. And then we have n to specify. I'm using n minus 1 to specify the n, so which n is referring to which column. Remember, we are still executing line 7. So the current context is really still column E to column G. Column E, F, and G is my current context. So in order to compute the expression n minus 1, that n is the one that is already established, which is column F. Column F has a value of 3. 3 minus 1 is 2. What do I do with that value 2? To specify the new parameter. The new parameter is the one that is living in column I. So that one is the one that is getting a value of 2. Column J is used for parameter R. And as I said, we are just passing the reference along. So it is the same as column G. In other words, we do not say this is also known as column G because we do not specify an alias of an alias in this class. Are we doing okay so far? How we set up columns H, I, and J. Is that okay? Okay. Now we continue execution inside the subroutine, starting from the beginning on line 4. N equals to 0 is once again false. And then we go to line 7 again. This is a good time to split the screen this way. And we can make it just a little bit wider, just so that we have a little bit more space. So once again, we set up return line number, we set up R, N, and R. R is just passed along the same way as before. It was an alias of column D before. It is now an alias of column D. N is 2 at this point, so the new n becomes 1 because it's one less than what it used to be. And then since the invocation is on line 7, the return line number is line 8 because line 8 does have something to do. So now we have set up the new columns for the next invocation. Once these columns are set up, we continue execution in the subroutine that we're invoking. In this case, it is line 4 again. N equals to 0 is once again false. We go to line 7 again. And by this time, things should get a little bit boring. Is it? Okay. So I'm just going to be lazy here and just copy and paste it and change. The only one that requires some change is n itself because we are passing n minus 1 to n. So when it was 1 before, now it becomes 0. And we'll adjust the width of the 3 columns. Now we continue execution in the subroutine that we're invoking from the beginning, which is line 4. Line 4 is re-evaluating n equals to 0, and for the first time, it is now true. Woohoo! We go to line 5. Line 5 is going to change R to 1. So we look up what R is, which is in column P. R is an alias of column D, which means we do not change column P, we change the column that it refers to, which is column D. So column D at this point is now changed to 1 from unknown. After line 5, we get out of the conditional statement because that's the only thing we have to do in the then branch. We end up on line 10. Line 10 is the end of the subroutine. We look at the rightmost return line number, which is line 8, which is telling me to continue on line 8. Okay, make a note of that. Now we have no use of these 3 columns in the allocated. Are we doing okay so far? Okay, so now we continue execution on line 8. But remember, columns N, O, and P are now deallocated. So we should not be looking at these 3 columns anymore. So I'm going to adjust the screen. So now we re-expose columns K, L, and M while we execute line 8. Line 8 is an assignment statement. The right-hand side refers to R and N, and we want to do a multiplication. R is referring to column D. Column D now has a value of 1. N is referring to column L, which has a value of 1 as well. So we have 1 times 1, which is 1. The left-hand side of line 8 is R, which refers to column D. So column D is now updated to a value of 1. And because line 8 is the last line of the else branch, we get out of the conditional statement, and then we end up on line 10. We use the return line number to remind us where to go, which is line 8. And then we have no use of these 3 columns anymore. Deallocate those columns. And now we continue execution on line 8. But the context is no longer columns K, L, and M, because these 3 columns are now deallocated. So we have to shift back to columns H, I, and J at this point. And we're still doing okay so far with this trace. Okay. So at this point, I'm back onto line 8. Okay, so I'm back onto line 8, and once again, we want to compute the product of R and N. R is not referring to column D, which now has a value of 1. N is column I, it has a value of 2. 2 times 1 times 2 is 2. If we store the 2 into column D, because R is a reference to column D. And then we end up on line 10 again. We do exactly the same thing. Look at the return line number, make a note, and then deallocate the 3 columns. Yep, we're just unwinding the whole thing. We're just going all the way back. And now we're going to run out of space vertically. So I'm going to split the screen in this way. It's kind of cool that we can do that. Okay, so now we are back onto line 8. We are executing it in the context of columns E, F, and G. Line 8 wants to compute the product of R and N. R refers to column D, which now has a value of 2. N is a bi-value parameter. It has a value of 3. 2 times 3 is 6. We store the 6 into R, which is a reference to column D. So that's why this is where we store 6. Then we continue on to line 10. We look up the return line number. We make a note that we have to continue on to line 14. And then we deallocate the columns for this particular invocation. And now we are on to line 14 again. Line 14 is n-defined sub. So that context is already up here. So we look up the return line number. It tells us to continue execution at post. And then we have no use of these 2 columns anymore. And deallocate them. But the point is, 3 factorial was actually computed correctly and stored in local variable x of main. Yep.
For purposes of tracing, this is really good to see how it works to go through it, but it seems like it's memory intensive.
It is memory intensive, or more so than a loop-based approach.
Yeah.
But recursion has its own strength. Factorial can be done easily with a loop too, so that's why it's not quote-unquote a good example, because it can be done with an alternative approach, which is just as easy to understand and even easier to implement, to trace. But for certain other things like removing a single folder, that is much more difficult to express if you do not use recursion. The recursion of a remove folder kind of thing is to say, okay, look at each item and make sure that each item, if it's a folder, it is empty first. So you move into that folder and then you say, okay, all of your subfolders need to be empty too. You go to the first one and then you say the same thing. So that's why in certain cases, recursion is a lot easier to express. In other cases, like this one, it's kind of like a toss up, Yep.
So because you're deallocating all the subsequent columns, all the values of those columns also get deallocated by default.
That is correct. So in a program like this, it is very likely that you probably have some kind of print statement between line 13 and line 14. So as soon as you get the result back, you're going to print it out or use it for some purpose. But in this program, I'm just using it as an illustration, so that's why it's not utilized before it is deallocated. Okay. Are there any questions about passing by reference in this case?
So when you hit post at the value X, does it exist anymore? It's just the value of the column?
Say again?
When you hit post there, the value of X is not 6 anymore, it's the value.
There's
the value
no
of the
X
column,
anymore.
no X.
By the time I get to post,
It's column D.
it's deallocated. There's no column C and column D are now deallocated. So I have no access to the computed value already. If you want to do anything about 3 factorial, you have to do it between line 13 and line 14. So you have to insert additional lines between line 13 and line 14 to make use of the value of the factorial.
Say to display it to the screen.
To display to the screen or to compute the chances of winning the lottery or something like that. Yep. That's actually how factorials can be useful, is to compute chances. Okay. Any questions about this part? No questions? Okay, so let's take a look at the inventory, okay, of what we can do with subroutines. We can invoke a subroutine and get back to the line below the invocation. Okay, so that's useful because if there is something you want to do over and over again from different places of your program, now you only have to specify the code once and then use multiple invoke to get to that place. Okay, so that's really good. The second thing we can do are local variables. Okay, in other words, we can say, okay, this subroutine has variables that are local to that particular invocation, that nobody else can mess around with these local variables unless you have passed by reference. Then you're basically giving somebody else permission and say, okay, here is where you can find my variables and you can change it. Okay. We have passed by value parameters, which can serve as an inbox. Okay. We have passed by reference pass by value parameters as inbox, pass by reference parameters as basically in-out boxes, so that the subroutine can change the variable that belongs to somebody else. So it seems like from the perspective of a subroutine, we got everything that we need because we have things that are local to the subroutine that nobody else can mess with. We have ways to pass information in. We have ways to pass information out. So it looks like we got everything done. Well, that is kind of the result. I mean, we do have everything we need, but it doesn't give us the convenience. Okay, there's one little convenience thing that we want to do in order to make the programs a lot easier to understand. So what I'm going to do now is I will use this as an illustration to demonstrate what limitations we have at this point. So we'll go ahead and take a look at the expression. Let's say I want x to get the following result. Okay, so we wanted to get a result of 2 plus 3, the whole thing times 7, and then I want this entire thing to be divided by, well, doesn't matter, another sum. Okay, so we want this whole thing to be divided by these 3 plus 4. Okay, that's what we want to do. Some of you look at this and go like, yeah, I know the result already. It's 5. Yes, I know you can do that all that math in your head, really quick. But this is only used as an example. Okay. What we have right now is a mechanism where if you want to pass any information out of a subroutine, it has to be stored somewhere before it can be used again. Okay? Does everybody understand what I just said? Okay, passing by reference is one way to pass information out of a subroutine, but in order for this mechanism to work, you need a place to store the result before the result can be utilized again. Okay, so let me illustrate what I mean by that. So let's just say that we can only do one operation at a time. In other words, I can specify addition, multiplication, or division on a single line. Okay, so that means something as simple as this will have to be broken up, because I have to first compute 2 plus 3, and then I can utilize the result of 2 plus 3 and say, oh, x gets x times 7, So that will handle the dividend side, the entire dividend side. Then we have a problem because we also need a second variable to store the divisor part. And now we can say, okay, x becomes the dividend divided by the divisor. So we need, in this case, 4 lines and 2 variables to accomplish the same thing that we can do with 1 single line up there. And the limitation is basically analogous to the limitation of passing by reference. Every step along the way, whatever we do, we have to store the result of an operation first before we can utilize that result again. Am I making any sense so far? Some of you, maybe? Okay. Because I can write a subroutine to perform addition, no problem. I can write a subroutine to define multiplication. I can write another subroutine to do division. But in order to compute something like this, I have to use variables x and y in this case to store the temporary results before I can finish the entire operation. It can be done, but it's cumbersome. But not only is it cumbersome, it is also prone to mistakes. Because what if I accidentally use x again here? Then I have a problem, right? Because I would have overwritten the dividend that I have to use for the division. Okay. So it looks like we can improve how we do things. Okay. In other words, in subroutines, passing by reference is one way to get a result out. But I think it may be helpful if I can use another mechanism to pass the result out of a subroutine, so the result computed by a subroutine can be used right away. It doesn't have to be stored somewhere first. Okay, let's look at this example again. What did I do with the result of 2 plus 3? Did I store it somewhere else first? Well, kind of, right? Because we have to first compute 2 plus 3, oh, it's 5. But I don't really store 5 into x or y in that particular expression. I immediately make use of the sum and say, okay, next we want to multiply that to 7. Do I store 5 times 7, which is 35, to a variable first? No, we just mentally keep track of it and say, okay, that's my dividend. Now move on to the other side and deal with the divisor. Okay? So we want something that is similar so that we can chain the invocation of subroutines. So instead of having to store the result first and then make use of the result, we want to just do it in place. Okay? This is the invocation. I want to make use of the result of that invocation right away. That's the mechanism of returning a value from a subroutine, okay, which is our next topic. And right now, it is a good idea to introduce, another concept in programming that you probably won't see again until maybe in your 4th year at a 4-year university in a compiler class or a programming language class. Okay, let's go back to this notation here. This notation has a name. It is called the infix notation. Infix notation means the operator, addition, multiplication, and division in this case, the operator is between the 2 things that it's supposed to operate on. Is that okay? Infix, I-N-F-I-X, infix notation. Okay, so I'm going to show you here infix notation. In this case is 2 plus 3 times 7 divided by 3 plus 4. Okay, that's how we learned how to deal with expressions. Okay, and I have no idea why we, as humanity, chose to use the infix notation. It's probably the same mystery that explains why we use base 10, which is a completely awkward base to use. Okay, base 2 would be good to use, base 4 would be good to use, base 16 would be good to use, but base 10, just because we have 10 fingers, right? But we can just say, let's not use the thumbs, then we can use base 8, which is still a lot better than base 10. Okay, so this is called the infix notation, which is what we grew up with. This is what we are comfortable with. The next one is called a prefix notation. The prefix notation is actually similar to subroutines because you specify the operation first. So in order to express exactly the same thing here in the same order, what I'm going to do is to say, okay, let's do 2 and 3 addition first. Okay, so this is specifying what I'm doing an addition with whatever is following. So I'm adding 2 and 3. What am I going to do with that sum? Well, let's do a multiplication with 7. What am I going to do with that product? We're going to do a division. But this is going to specify only the dividend. This is going to specify the divisor. So this entire thing becomes the same expression. It's called the prefix notation because the operation is specified before the things that it's supposed to operate on.
Don't some calculators work that way?
Yeah.
No, it's called the postfix notation, which is the next one, which is even better. Okay, the infix notation a lot of times does not require the use of parentheses. But in this case, other than the parentheses surrounding the multiplication, the other two parentheses, the other two pairs of parentheses are required. Because normally you perform multiplication first and then you perform addition. But this time I need to add 2 and 3 together first, and I need to add 3 and 4 together first. So that's why those parentheses, those pairs of parentheses are required. In prefix notation, you always use parentheses because you always specify the operation and then whatever you're operating on, and then use parentheses to surround the entire operation. So there's no ambiguity. The postfix notation is going to be the really, really awkward one because it has no use of parentheses. How can we do something like this without the use of parentheses? This is how it's going to be done. You specify 2, and you say, then you specify 3. So at this point, you got 2 numbers, on your hands. Okay. Then you specify, what am I going to do with these 2? Okay. What am I going to do with that, number 2 plus 3? I'll tell you later on. Okay. But you got 1 number on your hand right now. So the next thing I'm going to do is to give you a second number. So at this point, you have 2 numbers again. You have 5 and 7. What am I going to do with 5 and 7? Let's do a multiplication. Once you do a multiplication, you have 1 single number left because you only have the product of 5 and 7 left on your hand. So once again, you only got 1 number on your hand. What am I going to do with that product? I'll tell you what to do with that number next. But first, I'll give you 3, and I'll give you 4. And then I'll say, oh, those two numbers that I just gave you, do an addition. So that will consume the 3 and the 4, but in return, it will give you the sum, which is 7. So now, once again, you have 2 numbers on your hand. You have 37, and then you have 7.
35.
Oh, 35, excuse me. You have 35 and then the 7. So what am I going to do with those 2 numbers? What about a division? So that's how you specify exactly the same expression, but using the postfix notation. Yes?
Isn't that not as clear? Because it kind of looks like you should add 35, 3, and 4 all together.
That's because we are still thinking in the frame of infix notation.
So how do you assign postfix notation?
How do you do the assign thing? Oh.
Well, how do you tell someone that you're using postfix?
Oh,
notation?
well, some calculators can switch mode. Okay,
Okay.
you can basically go to the mode operation or the setup part of the calculator, and you can specify whether you want to use the infix notation or whether you want to specify to use the postfix notation. Most calculators do not use a prefix notation because it is just a lot of parentheses to type. Yep.
But isn't the postfix so inclined to mistakes or in misinterpretation? Sitting back here, not knowing what you typed out, if I looked at it, it looks like 23 plus 7 times 34.
That's because but what if I told you ahead of time this is in postfix notation?
But then, again, I can't, it would be hard to see that depending on the type or the font, if that's a space between the 2 and the 3, or if it's just 23.
Oh, well, if you're just looking at it, if I don't tell you ahead of time, yes, it will be difficult to see, to see whether you should use the infix notation or the postfix notation. So I do have to tell you ahead of time that you have to use one way or the other to interpret whatever is following. Let me answer your question and then yours. Yep.
I was gonna say, like, I tutor for people who are like below Algebra 1, and I feel like this would almost make more sense to them. Like, just because of the way that it's like, well, you do this first, and the fact that there's only one like sign of what to do, that means that that's all you're doing. That if you get to the double sign at the end, you're doing well for them.
In a way, okay, let me answer the other question first, and then I'll go back to this. Yep.
It's a quick one. How do you separate like double-digit numbers if you were to say?
Without a space.
Just that's it.
Yep. Yep. Okay, so it seems like infix notation, we got it. No problem, because that's how we learn how to express mathematical expressions. Prefix notation, I think most people feel that it's okay. Okay, we can specify the operation first. It still has a lot of parentheses to specify, okay, what do we need to do first, and then what do we need to do? Postfix notation, I think, is the most difficult one to a lot of people because there are no parentheses. What am I going to do with this? Okay. Well, as it turns out, postfix notation is used actually quite a bit. Okay. The reason why postfix notation is used a lot is because it is extremely easy to parse. In other words, it's very easy for someone to write a program to process postfix notation as opposed to infix notation and prefix notation. If I have to order these in terms of implementation as a programmer, how to read and interpret and evaluate these expressions, the easiest one is postfix notation. Okay, that's the easiest one. The second easiest is the prefix notation. The most difficult one is actually the infix notation, even though to humans it's quite the opposite order. And that's why in early days, the HP calculators, if you know someone who's in there, probably by this time in the 50s, and they are engineers, who deal with a lot of calculations, they probably can do any type of infix notation and translate that into postfix notation in a fraction of a second, because that's how they grew up with, calculators that can only do postfix notation.
I think my grandpa still has his first calculator that did that.
Yep, yep. And for those of you who want to experiment, you can actually go to an Android Play Store and look for RPN, reversed Polish notation, and you can actually download calculators that make use of the postfix notation. Yep.
So if you had in the original problem more numbers to add, like say in the first part, you could just there's no limit to the numbers. It's just all the numbers and then followed by the operation that you perform on all of those. Or like if you had 2 plus 3 plus 6, then the postfix would be 2, 3, 6 plus.
Plus. No, plus, because each plus will only consume 2 items.
Okay.
So the plus, is specific. It will consume exactly 2 items, but it will give you the answer, which is 1 item.
Okay, so if you have more than 2, you have to put an extra sign.
Right. If you want to compute 2 plus 3 plus 4, you have 2 alternatives. Because you can say 2, 3 plus 4 plus, or you can say 2, 3, 4 plus plus.
Right.
Both will do the same thing. Yep.
So it just reads left to right? Like there's no order of operation, nothing like
There's
that?
no implicit order. You just read left to right. Yep.
I'm still a little bit confused on the one part because so you've got 2 and 3 and then you add them.
Yep.
And then you multiply that by 7. So you're using those 2 numbers, but then how do you know that you don't add the because the plus only consumes
Okay.
2 numbers, right?
Let me do this. Let me see if this makes sense. Okay. So if this is the input order, so the first thing the computer would do is to look at these 3 items and say, hey, I know how to do this. This will give me 5, right? Mm-hmm. And then the computer would look at the next item, which is a 7. It doesn't know what to do with the 5 and the 7. They're just 2 values that you have on your hand. But then it will look at the multiplication and say, oh, multiplication needs 2 numbers. So I know what to do with the 2 numbers that are now presented to me. So do a multiplication, that becomes a 35. So now it looks at 35 and then it looks at 3, 4, and the plus. The plus only applies to the most recent numbers that you gave it, okay? So that means, the 3 and the 4 will become a 7. So at this point, you have 35 as one number, and then 3, 4 plus becomes the second number, which is 7. So by the time you get to the division, then it will give you, 35 divided by 7, which is 5. Yep.
So what he was saying, if before, like how if you want to do 2, 3, 6 plus, you would end up with 3 plus 6 and then a 2 outside of that.
That is correct. Then you have 2, and then 9, and then the plus. Excuse me, it's just 2 and 9, but you have not specified what to do with the 2 and the 9.
Gotcha.
Yep. Now,
see, I was wondering why, how you're supposed to figure out which numbers were used with the divisor. And that makes sense now.
okay.
So,
Yeah, because you have one floating number, which is 35, and I don't know what to do with it. And then you specify 2 additional numbers, which is 3 and 4. And then you specify the addition. So the addition only looks at the most recently given numbers, which in this case would be the 3 and the 4, and then perform the addition. That gives you the 7. Yep.
So if you entered it wrong, like you had an extra operator somewhere, is it just going to give you an error? Or?
Yep, that will give, well, it will do the computation, assuming there are enough numbers presented to you to perform the operation. The operation will be performed. Yep.
Are we going to be covering this on the test?
No, this is just an exposure
Okay, got
to,
it.
it is related to computer science,
Right, right.
because, the parsing part is important to, people who implement programming languages. Okay? And we have about 3 minutes left, which is plenty of time to talk about, the consequences of these, particular representations. Do you think any programming language in quotes, today, even today, make use of the postfix notation? The answer is yes, and can someone give me an example of a language used by computers that makes use of postfix notation?
Java?
Java is not. Java is C-based and it's infix notation. Has anyone heard of what is PostScript? PostScript
Yeah.
is a language, it's just abbreviated as PS in most cases. It's a language understood by printers. Okay, so instead of having your computer to send over raster information, which is, oh, here's a dot, this spot has a dot, this spot doesn't have a dot, this spot has a dot again, and so on, it's sending instructions to the to the printer and say, draw a line from this location to this location in in millimeters or whatever unit they want to specify. So now the same instruction can be sent to any printer. Whether your printer has a really bad resolution of 150 by 150 dpi to 1200 dpi to 1200 dpi, it's the same instruction. It's left up to the printer to determine where to put dots. Okay. Anything else? I mean, that's kind of like a really obscure language or format. What else? Have you guys heard of PDF, as in Acrobat Reader type of PDF? PDF internally makes use of postfix notation because it is the same thing. Once again, it is quote-unquote device independent. Draw a circle, the center is here, the radius is this much, and the thickness of the line is this much. So now you can render the same circle on a high-resolution monitor. It looks really good, and then on a lower resolution monitor, it doesn't look as good, but the scale is right. Okay, it's the same thing. And both of these two languages, PDF and PostScript, are from Adobe. And both of these make use of postfix notation to represent how to do things. Okay, center, radius, thickness, draw circle. That's how it's done. Yep.
Does BMP also do that?
No, BMP is a raster format, which means you're actually telling the you're storing, exactly the RGB values of each dot, and that's why it doesn't scale. If you have it's raster based and it doesn't scale. In other words, if you look at the picture, closer and closer and closer, you will start to see dots. But if it is PS or PostScript, you can zoom in and zoom in and zoom in, and you always have details. All right, I'll see you guys on Thursday.
Test on.
Next Tuesday. Yep.
What language do you see the future in?